particle having charge that of an electron and mass 1.6 into 10 raised to the power minus 30 kg is projected with an initial speed u at an angle 45 degree to the horizontal from the lower plate of a parallel plate capacitor as shown in figure. As you can see here, this is a parallel plate capacitor, and from lower plate a charged particle is projected with a speed u at an angle 45 degree with the horizontal. Upper plate is shown to be at a separation of 2 cm, and the plates are sufficiently long and have separation of 2 cm. Find the maximum value of the velocity of the particle so that it does not hit the upper plate. So we have to find the maximum value of this speed u, which is at an angle 45 degree to the horizontal, so that it may not collide or it may not hit the upper plate. Here, electric field in between the plates of the capacitor is given to be 10 raised to the power 3 volt per meter, and charge is given to be that of an electron. So this is negatively charged particle. That means it will experience electric force opposite to the direction of electric field. So force experienced by this particle would be vertically downward. So electric force would be acting vertically downward, and the magnitude of the force will be electronic charge multiplied with the electric field intensity, which is given to be 10 raised to the power 3 volt per meter. And here we can easily neglect the force of gravity. So we'll just consider the electric force. So let us assume that this is our x-axis and here it is our y-axis. So when particle is projected from this point, let us select this point as our origin, and y-axis perpendicular to the plates. So this is our y-axis. Okay, so u is velocity. So we can take component of this initial velocity along horizontal and vertical. So components would be u cos 45, which is u divided by under root 2 meter per second, and in the same way the vertical component will also be u by root 2 meter per second. Okay, so x component of initial velocity is u by root 2 and y component of initial velocity is also u by root 2. There is no acceleration in the horizontal direction, but there is some acceleration in the vertical direction. So acceleration along the y-axis is going to be what? Since it is vertically downward, so we'll take it to be negative. Okay, so it will be E, capital E, divided by mass of the particle. Mass of the particle we know is 1.6 into 10 raised to the power minus 30 kg, that we can put finally. Okay, so this is y component of acceleration. Initial velocity along the y-axis in terms of u is u by under root 2 acceleration we have. So we'll find the maximum height attained by the particle, means the maximum possible value of the y coordinate, because here you can see initial velocity is vertically upward but acceleration is applied vertically downward. So vertical component of velocity will keep decreasing and finally it will reach a certain point that will be its maximum height. Here you can see in this particular animation that this particle is projected with initial speed u at an angle 45 degree to the horizontal, and since electric force is continuously acting vertically downward, so you can see that particle will start following a path same as that of the projectile. Here electric force is acting as the force of gravity that was in case of projectile motion. So here we are interested in finding the final y coordinate when its vertical component of velocity becomes 0, because that will be the highest point of the trajectory. So we'll assume Vy equal to 0, and then let us apply the third equation of motion, which is Vy square equal to Uy square plus 2Ay Sy. Sy is the displacement along the y-axis. So here we are assuming it to be y. Suppose here there must be some x coordinate and some y coordinate. So y is the y displacement along the y-axis. So for maximum value of the Sy, Vy is 0. equal to uy square. Uy square means u square divided by 2 plus 2ay. Ay is minus ee divided by m into y. So this is something that we have got. Okay. And here maximum value of the y should be what? 2 centimeter. It should remain less than 2 centimeter. In fact, y here you can see that y can be written as, or you can write y, it is y equal to m u square divided by 4 e capital E, and it should remain less than or equal to d. Here d is 2 centimeter. That means d is equal to 0.02 meter. Okay. So this is the relation. That means u square should be less than or equal to 4 small e capital E into d divided by m. So we have all the values. Small e is 1.6 into 10 raised to the power minus 19, and capital E is given to be 10 raised to the power 3 volt per meter. Small d is given to be 0.02 meter, all in MKS, and mass of the particle is given to be 1.6 into 10 raised to the power minus 30 kg. Okay, so we have all the values. So you can easily calculate what should be the maximum. It was asked that maximum possible value of u. So u should be less than or equal to this value, means this is the maximum possible value of u. So just calculate it and you will get answer to be 2 root 2 into 10 raised to the power 6 meter per second. So option A will be the correct option.